add that new constraint. Okay, so I add that new constraint, that minimum constraint, which wasn't there before, and say, and I don't care which direction you do it, this minimum value needs to be less than what is assigned, okay? Or you can say what's assigned needs to be greater than 1, you know, but you gotta put them in the right. It's okay which way you put it in, but you gotta put it in the right. That new constraint has to be added to this model, and then I solve it. And it turns out that making employee 6 have a job increases our time by 10 minutes. And that's sort of to be expected. I mean, obviously the reason we didn't use employee 6 before was because it was going to take longer, and it was a minimization problem trying not to take longer, okay? But when we impose a new constraint, or we tighten a constraint in some way, we're almost always going to make our objective worse. It could stay the same, it will never get better. Okay, it wasn't going to get better by adding this constraint. I mean, why would it get better? It didn't want to use employee 6. Now we're making it use employee 6. Of course, not better. The time's not going to be better. Typically, it will be worse, and the worse is in a minimization problem is that it takes longer than it did before, because we have to include this employee. You know, has to have it. And I could do what I just did here, or I could have done the same thing here. Okay, and I would have grabbed that information right there, and for sure wouldn't add columns in this one because it'll mess you up. And I would have cut it and moved it over to, so that I would have a spot for a min. And in a logical location, because I think it's logical, okay, and in a logical location that sandwiches this in between. You have to at least have 1. You can't have more than 2. Now I haven't put an input up here yet. I am going to have to go up here, like add a new min assignment 1. Okay, I do need to now reference that cell. And absolute reference that cell. But modifying the structure of the spreadsheet's not enough. I then have to go into Solver and add that constraint. It's a new constraint. It has to be in here. So I add that constraint saying, you know, the minimum value has to be less than or equal to what we assign to them. Because prior to that, employee 6 isn't getting a job. So I just did the exact same thing, only I did it to this structure, to the list structure. And of course, again, this goes up 10 minutes, it's 273, the new, you know. But that's, you know, that's just the reality of working with a spreadsheet and saying to yourself, a solver model, and you solve, and then you look at the outcome, and you sometimes see things you hadn't anticipated happening. We hadn't anticipated that one of our employees wouldn't be assigned a job, you know, that wasn't best time-wise, you know, optimal time-wise. And so we had to, you know, go out of our way to cause another constraint to be in there to make it a minimum of everybody gets a job. And we could do it on matrix, we could do it on list. Questions about either one of these before we move to the next example? Oh, I'm not going to forget in this class. I've forgotten the last 2 classes, but before we move to the next example, and you'll see this on the finish file, so you would have wondered, oh, I don't remember doing this if we don't do it. There was a part of that problem, that number 70 in chapter 5, that says, you know what if we allowed the maximum number of jobs to be something higher than 2? I mean, if you're really speedy, you should be able to get more jobs, 3, 4, 5, okay? So let's do a solver table to check that out. So that's the only thing I'm going to change. So it's going to be a one-way table where I'm going to say, and mine's in B3, but that B3, let's give it a name, max jobs per employee. Okay. Then, hey, what, you know, they're fast. We should give them more jobs. So we'll start at 2, but go up to 5 in steps of 1. You know, how would that our overall cost. If the really fast people were doing most of the jobs, okay? So I'm taking that max charge, but I've got it in B3, and I'm going from 2 to 5 in steps of 1, and I'm gonna look at that overall time, my objective cell overall time. When I solve that, what I discover is it only helps just a little, okay? And you kind of can see this because there were 15 jobs and 10 employees. 10 jobs are spoken for, like they're assigned to someone, and you only have 5 left over that can be given as extras to anyone. And so I suppose if there was one employee who was Speedy Gonzalez, you could give them all 5 of the other, well, you couldn't, we just went up to 5, we could go to 6. But anyway, you could give them that. But that doesn't appear to be what happened. That when we went from 2 to 3, yes, we did reduce, okay, relaxed to constraint. So we actually did reduce our objective function. We reduced that overall time to 271. So obviously we gave someone 3 jobs. Maybe it was only one person, maybe it was a couple people, I don't know. We gave someone 3 jobs and the time got a little bit better. But after that, the time doesn't get any better. So I guess we don't have that much difference between our employees and their speeds, like where there's one really fast person. So it must be still somewhat balanced to the extent that it doesn't help us to increase that to 4 or 5. It doesn't help us at all, okay? Increasing it to 3 did, saved a couple of minutes. Okay, but increasing it to 4 or 5 doesn't really do anything else for us. All right, any questions about that solver table? And you'd see this on the finished file if we didn't do it, you'd think, remember that. Okay. The last problem that we're gonna do has a lot of iterations to it, and it's this problem when I said you've got these professors who have given you their preference rating, essentially satisfaction rating, for teaching at these different times of day. Okay, some of them would rather teach at, 2 o'clock or 9 or 10, or this person doesn't want to teach. No, just kidding. So you've got all these different preference ratings in here. We call them satisfaction ratings. I do need for all of us to go up here between assigning professors and satisfaction rating and put 4 new rows in. I can't remember if I need 3 or 4, so let's just put 4. Okay. Insert 4 new rows in there, because I know for sure, I think there's going to be 4 new inputs, 1 at a time. We won't be doing them all at once. Okay, let me start. I'm molding these cells, it's not like Let me start by explaining the problem to you. We have these 6 time slots. We have 3 professors, and each professor is going to be teaching 2 classes. So classes, or class is per professor, they're each going to teach 2. Okay. Now, since they're each teaching 2, and there's 3 of them, that's 6 classes, right? And we have these 6 time slots. So if we want to be really nice to the students and not overlap classes and make it easier for them to enroll and stuff, we ought to go ahead and just set a rule that says we need to put those 6 classes, 1 in each time slot, okay? So we're going to do another constraint that says classes per time, and say there needs to be 1 in each time slot. No reason to double up when you've got enough time for classes to not conflict with each other. Okay, we're going to start with that. I don't know why this doesn't have better words in it, but we always do this in a transportation or assignment problem. We're going to have to figure out how many classes a professor gets assigned to and make sure that it's 2. Okay, so I'm going to do what here? It says it right there. Okay. I'm going to sum, because I'm always going to sum the rows and the columns of the matrix. I'm going to sum that up for each professor, because I need to make sure they teach 2. Okay. I'm not going to put a 2 in here. I'm going to reference the cell up here that says 2 for how many classes the professor's teaching, each professor will teach, and I'm going to absolute reference that. So that should be in B2. If you put yours where mine are, that should be B2, absolute reference to it. Copy it down. So if I'm saying each professor teaches 2 classes, what logical operator should I put between these 2 things? What was that? Yeah, I would just put equal, let's, you know, we need to put an equal in there. So we're gonna put an equal, because that's what we want them to each teach. All right, we have to make sure that each time slot gets a class, okay? So what do we do here? What do we always do here? Sum it up, sum up that column. And all the columns. Because it's required that each time slot has a class. So I'm gonna reference, I'm not gonna put one, I'm gonna reference that one up here, absolute reference that one up there. Mine's in D3, yours probably is too. So that we're going to force there to be a class at each time. So what logical operator do I put in here? Equals. And how do I get the total satisfaction rating? Yeah, there is some product of both the arrays. Their ratings for each time slot and whether or not they get assigned to that time slot. So again, if there's 0 there, you know, then it doesn't get factored in. If there's a 1, that means they were assigned to that class. We take that rating, we add it into the whole total. And that's it. And you notice I have no disallowed paths in this one. So it's a very, very small problem because the purpose behind it is something different, but we're gonna keep iterating through it, doing different things. So I am gonna solve this one. My objective cell is total satisfaction. I'm trying to make professors happy, so, you know, maximize that. So total satisfaction needs to be as high as possible. I'm doing that by changing, the changing cells. But for an assignment problem, it's this whether or not something is assigned at each of these slots, these people to these times. Nothing to worry about, so there's no disallowed. And I always have how many constraints? Or at least I start with, how many constraints? 2. The 2. They're always on the totals of the rows and the totals of the columns, and the context just varies depending on what the problem itself is. Okay. In our problem, it's making sure that every professor gets exactly 2 classes. So I'm doing this. And the other is to make sure every time slot gets exactly equal 1 class. So those are my 2 constraints always. I mean, greater than is less than, the context changes, but that's always that and that in some form or another. Those are my only 2 constraints in the problem now, right now, okay? So I go to solve this. I have a very easy solution to this, although the first professor may not like it because they teach at 9 and 3. The other 2 get back-to-back classes. All is good. This total satisfaction is 46. I do want to show something else. I do want to put in here, what's the satisfaction per class? Because I think that that would be interesting, because if we change the number of classes, well, the total satisfaction rating, if you taught twice as many classes, will be twice as much. You know what I'm saying? So if we really want to compare apples to apples, or could be, we want to actually be looking at the average on this. And so I'm going to look at what was my total satisfaction and divide that by however many classes will end up being taught. I need it to be in here as a formula like this because we will be changing those. We will be changing how many classes are taught. So I want to see the average satisfaction rating. So it's 46 overall, but for the 6 classes, that means on average, the satisfaction rating per class is 7.666 repeating. Okay. Okay. Everything good? Right? We get word back that the professors need to teach 4 classes each. So I'm going up here in B2 and I'm changing this to a 4. Okay. If I'm going to change that to a 4, okay, there's 3 professors. Okay. There's the 6 time slots. Well, I can't just have 1 class at each time slot now, can I? I need to have how many at each time slot now? 2.